Okay, good afternoon to all of you. Today we shall see what all is happening behind the scene when the objects are created. In fact, if you remember in C programming, we discussed at length the memory layout of C program. The memory layout of C++ will also be similar to illustrate what all is happening when you actually define a class and create an object of that particular class. So for this, I have taken a very simplistic example. You are all well aware that class employee has employee ID. Then we have employee name, and then possibly can add salary. So there is one, this can be a simple variable, not a pointer. Yeah. Then in the public section, I have added a constructor. So you know what a constructor is by now. Constructor is used to initialize the data members. So I'm using inline initialization of data members. As you can see, employee ID bracket 100, employee name Faisal, salary this. And you should end the constructor with a opening closing flower bracket. And sometime back I mentioned about destructor. Along with the constructor, we also need to have a destructor. So destructor start with tilde symbol, which is a key on the right hand side top corner of the keyboard. And the name of the destructor will be same as that of the class name. And within that, you have to perform some
Dix-
memory related operations. You have to free up the memory.
it should be destructor, no? Constructor called is.
Sorry, this is destructor. The destructor's role is to, free up the memory that is allocated dynamically. We shall see through an example. And I've added two simple methods. One is hike salary, and second one is just display the employee information. Now, in the main, I'm instantiating an object of employee class. So what really happens in this case? So if you look at this uh, memory layout of a C++ program, it is very similar. On the top, you have stack, and below this is the heap. The heap grows upwards, and the stack grows downwards. Okay, and this is where your program will reside, the main and all the methods of your class. So when you create an instance of a class, the memory for all the data members will be allocated in the stack here. So for instance, here first data member is employee ID. So EMP ID will come here. One, I'll just write it completely. EMP ID will be placed here, 4 bytes. Then employee name would come here. So this may occupy some fixed length, maybe 20 bytes, 80 bytes, depending on how the compiler is configured. And then the salary. So memory is allocated for all the data members of the object. So when you create one single object, this is what happens. And when the constructor is called automatically, the values are initialized to the initial values 100 here. Then this is going to be Faisal here. And this is going to be some 65,000. Okay. So this is how object gets created, and this is where your object E is placed. Okay, so the address of object E is assuming it to be 4000. So this is where object E will be allocated. What happens if I create one more object? Let us say employee E1. What do you think? What will happen?
Other object will be created down
Another
below.
object will be created exactly. So may float is 4 bytes. So from 4028, you will have another employee ID here. Maybe this time, since you are doing default initialization, the data will be exactly same. Again, employee name. As you can see, the stack grows downwards. And more objects are created, the objects are allocated space. Now, the class also has constructors and destructors, right? And also the methods. For this also memory should be allocated, isn't it? So that memory allocation happens in the text part of your memory layout. Wherever you have main, just above that, so this is where the place for constructor is there, then followed by the destructor and all your methods here. So as you can see, there will be only one copy of constructors, destructors, and methods, irrespective of how many objects you create here. Okay, there are two objects now, E and E1. Though there are two objects, the code will be common to both. That you need to understand. Okay, so the objects are allocated in the space. So when the main function terminates here, when it reaches the closing bracket, the variables go out of scope, and this memory which is allocated here will be deallocated automatically. Auto deallocation happens. It means both the objects go out of scope. So there will be nothing left here, right? So the memory will be reclaimed, and next time when you run the program, the same memory can be allocated to, if this program is running, the same space is allocated to employee E and employee E1. If some other program is run, for example, car or any other class, so those objects will occupy this space, right? So this is a normal execution of a C++ program where when you instantiate an object, this is all is happening in the memory. Now there is one small thing I have to show here. When is the memory allocated on the heap? Okay. So suppose here in your employee class, suppose instead of normal variable, if I put a star here, what will this employee name be now? Will it be a normal variable or a pointer?
Pointer.
Pointer. Okay. So it means it cannot store the name directly here. What happens is this is gone. Here some address should come. Okay. Now again, coming down here, you cannot initialize the employee name like the way we are doing when it is a normal variable. Now I have to allocate memory for this object dynamically. So what I should do inside this EMP name is use the new operator. And you all know string is a class, so I would just call string, and strings constructor I am passing the name, whatever that name could be. Now for the second data member, memory will be allocated in the space. So this is where the memory will be allocated for the string. So this is where your employee name would come. This is where the string gets stored, and this 7000 is what gets stored here. So now you know that this is a pointer and it will point here. Okay. Now you might be wondering why such a thing is required. For a single variable, this may not be a requirement. Imagine there is an array of strings here. So then allocating memory dynamically would be more beneficial. We shall see an example of that kind subsequently. But what happens when you use a pointer instead of a normal variable and allocate memory dynamically? Okay. Now, as I told you, when you reach the end of main, the memory allocated to this part is reclaimed. Okay. But what is allocated in the heap, all this will be gone when you go out of scope. Let us say the main ends, all this is gone. This pointer is no longer useful. But this memory, which is here at 7000, remains allocated. Now, how do I free up this part of the memory? That is, how do I free up the heap memory? Now, that should be done in the destructor. In the destructor, what you should do after this statement here, this is where you have to say delete employee name explicitly. As I told you, destructor will be automatically called when you reach the end of the program. So this destructor will be called, you will get a message destructor called, and immediately after that the delete function will work on the object, and this memory which is allocated here will also be reclaimed and it is empty now. Okay, so
Can
yeah.
can we use delete instead of employee name?
Hmm.
Can we just give like delete employee, like
Okay,
as in
yeah.
capital
So
E employee?
yeah, your point is valid. If I say delete employee here,
Hmm.
or delete just E because E is the object,
Hmm.
only
Right.
this part will be deallocated. What is
Oh.
dynamically allocated will not be deallocated.
Mm-hmm.
Okay.
Okay.
So even
Okay.
if you
Can
explicitly delete object E, the
mhm.
heap part will remain allocated.
Okay. Can we use since we have used new? Can we use like a free of string name, meaning free of
No, no,
employee
that,
dot
that free
name?
function was in C.
Right.
Okay. Here
Okay.
in C++,
Okay.
it is renamed as delete.
Delete. Okay.
Okay.
Okay. So it is new is kind of like malloc and
Yeah, yeah. Deallocate.
delete is kind of free.
Yeah. So whenever you are saying new string, you are actually calling malloc function and allocating
Mm-hmm.
space for the string Faisal.
Mm-hmm.
And here you are actually calling the free function which you used in C program.
Okay. Sir, actually, I do have like, okay, let us think like employee one. Okay, we are at the below in the
Hmm.
wide main.
Hmm.
Okay, we have like employee one is equal to new employee. Can we have like that in that struct itself? You can call
Here,
yes,
in that
new.
case, this has to be a pointer.
Uh-huh.
Okay.
Okay,
And then say employee here.
okay,
This time what happens? This for E1, the memory
mm,
allocation will not be in the stack.
okay,
It will
stack.
be in the
Okay,
heap.
okay, and
Ah,
in that case as well, this
yeah.
constructor,
Hmm.
like what we have called new, that
Hmm.
will be allocated serially,
Yeah,
or
yeah.
it will be again a pointer
Where?
in the heap. If we see, if
Yeah, E
employee
name
is
again
done,
it will be dynamically allocated.
okay, again it will be dynamically
Yeah, so you are
allocated.
allocating entire memory for the object also on the heap. Now
Mm-hmm.
the E1, the object E1 will be in the heap. It will get
Okay,
allocated here. For
okay,
example,
okay.
7,000, let us say 10, your employee
Okay.
ID will come here.
Mm-hmm. Mm-hmm.
Then employee name,
Mm-hmm.
hmm, then again employee ID. So this may
Employee.
be 100 again, then this will be a pointer. If it is a pointer again, this
It
pointer
will
will
again.
point to some space in the heap only.
Okay, okay, understood.
Okay, so this is
Understood.
where again Faisal will be stored. Since we are using
Okay.
default constructor, all objects
Mm,
will have same data.
in data. Mm,
Okay,
mm,
so for this you have to free yourself. You have to call
mhm.
delete E1.
Okay, delete.
If you
Okay,
don't,
not
then again it will remain allocated.
okay. Okay, then it will
This
be deleted.
destructor cannot do anything about it.
Okay, okay,
Okay, so
understood.
it should be done outside the class if
Mm,
you are allocating memory dynamically. Okay,
okay.
so we'll illustrate all this through program, and
Mm-hmm.
you will know why I showed this diagram is you should know what is happening behind the scene.
Sure, exactly.
Otherwise, if I just say employee or employee star even, you don't know what
Mm-hmm.
is happening. Okay.
True.
Similarly, when you use delete here, what happens, and when you say delete here, what happens. So that all
Mm-hmm.
should be very clear, and you
Mm-hmm.
should get a clear picture of where the methods get allocated, and only one copy of the methods and the constructor destructor will be there. This much you must
Mm-hmm.
remember.
Okay, and if in the case of overriding, meaning we do have same function name with the
Yeah, yeah.
different
So
parameters, then
overloaded functions will also be here
o-
only in
overloaded.
the text
Okay, but
area.
in the different copy, but
Yeah,
it will be have a different copy,
yeah,
right?
yeah. It will have a
Overloaded.
centralized only one copy.
Okay, okay,
This much is
understood.
clear.
Yes.
Okay, so let's see the implementation part of it. Okay, so I will take the same class employee here and employee ID. Then first of all, I'll take simple normal employee name as a string variable, not pointer. Okay, and then you have the salary. Okay, and then in the public part of this class, I should have the constructor. So I have a default constructor here, and again it is inline initialization. So employee ID will be, let us say, 101, comma, employee name then salary. It's a real number, and then it should end with opening flower bracket. This is the constructor, and destructor will follow just employee, again opening closing bracket, and in the flower bracket I will write one cout and say I am destructor. Now in this case the destructor has no role to play because none of the data member is dynamically allocated space. All these are allocated on the stack. Okay, so just for demonstration whether it gets called automatically or not, I have put this destructor. Okay, and then we can have the method hike salary by how much percentage you want, that you indicate here, and update the salary plus equal to whatever is the original salary multiplied by percentage and divided by 100. Since both are integers, I have to convert one of them to float. Yeah, so this will hike the salary, and then we shall have one more method, display employee info, which will see out all the three data members. So employee ID, bit of space here, employee name, bit of space, then salary, then enter. Okay, and then semicolon here. So our class definition is done. Okay, and here if I create an object employee E, this will be allocated in the stack. Okay, now if I call the hike method, let us say 10% hike I'm giving, and then e dot display info I will invoke. So what should happen? I can remove this hello world. So what should happen? It should call constructor here and then initialize the data members using the default values. When you hike salary by 10%, whatever is the 50,000 salary, it should become 55,000, and it should display accordingly here. So if I run the program, and when this main method ends, the destructor will be automatically called, and you will see at the end I am destructor as last statement in your program. Let's see whether that happens. Okay, so the employee details are displayed with 5,000 hike here, and I am destructor is automatically called when the program ends.
Okay. Sir, in line number 8, within the curve braces, if you want to put, can you put any scene statement or cout statement kind of like that, or
Where line
in
number?
the line number 8 in the flower braces, inside flower braces, can you put like cout flower braces at the end of the line?
Where you want to put and
At the end of the line, cout there in that particular.
Okay, you want to check whether constructor is called or not.
Okay, yeah.
You can say constructor called.
Mm-hmm. Meaning, I just wanted to like when it is exactly called. After that,
no. When the object is created, at the time of creating the object, as you can see, constructor called, and then values are displayed, and destructor is called.
Display info, and then okay.
Okay. So is this pretty clear now?
Yes.
Okay. Now, if the second data member, if it is a pointer, then it has to be allocated space on the heap using new operator, and then using the class name string here. So class string is also a class. Remember, it's a library function which has a constructor and accepts a string as an argument. So this is an object which is created on the heap now. Okay, and everything else remains the same, except that while displaying the employee name being pointer, I should dereference with a star here. All of you agree? If you remember, when you use pointer, the content of the memory, if you want, it should be with star employee name. And now in the destructor, I have to delete uh, your employee name exclusively. Otherwise, the memory remains allocated. So instead of I am destructor, here I say memory deallocated. Okay, so when the object goes out of scope, destructor is called and memory is deallocated for the data member. Okay, so everything else remains the same. Now you see the constructor is called memory deallocated for the data member. Right, the data remains same. Are you getting this point? Okay, and the other thing which you asked, that if I want to use new operator here, then it should be star E1, and then it should be employee with opening closing bracket, of course. So this time what happens? Object E1 will be on the heap, where object E is on the stack. So it is your responsibility to delete E1. Okay, and before that I will just execute some methods on E1 also, so that we get data about both. So here also I will do salary hike of 20%, and E2 arrow, I must be using arrow here.
Even
E1
not
arrow display info. Okay, so now we will get the same data twice with the 20% hike. With 20% hike, we are getting this. So as you can see, both times the destructor is called, because there is one dynamic
there are
data member
two
which has to be
objects.
removed. Correct? Okay, so would you like to try this out? Yes, just give a try.
Fine by me, or if anybody has concern, maybe we can go.
Yeah?
No, if everybody are okay, fine. If not, we'll go.
No, we'll try, sir.
You
Okay.
will try, no? Okay.
Yeah.
Spend some time, because what happens, you may feel you have understood everything, but while doing, you may face some issues. So I want
Yes.
you to give some time. Okay, so here you are doing the default constructor. If you wish, you can add a parameterized constructor like employee, and here int id string name, then we have float sal. Within this you can have employee id assigned to id, employee name assigned to name, and here possibly you have to pass the address because it is a pointer, and then you have salary which is assigned to sal. So this is a parameterized constructor, so that you can try with object E1 here. Okay, you complete this, I will show you that. So as you can see, both objects are showing the same data. With parameterized constructor, second object should show different data. So that part we should check. What is the error you said?
The error is some. So I pasted in the chat.
Yeah. Now moving on, there are a few things that you need to understand, that there is a concept of a friend function. Okay, so why friend function is required we shall see subsequently. For example, here there is a function y, let us say mm, give perks and some fixed amount. So this is what should be added to the employees. So okay, it should be defined here. Okay, you have to pass the salary also from here. So you can define a normal function, okay, outside the class and make it part of the class. Okay, so why this is done is that in some cases certain functions are required by many classes. You have employee class here, probably you have another class called as manager class, another class called as clerk class. All these things may require this give perks function, right? Instead of implementing in every class, we can make it a friend of all these classes so that they can be accessed like this. All right. So a friend function is a useful utility which is frequently used in C++, right? And next point is getters and setters. Now we know that the data members here are all private, isn't it? Employee ID, employee name, and salary are private. But if I want to access them in main using the dot operator or the arrow operator, I should still be able to do. So we can define getters and setters. I'll show you for one example. Suppose if I want to access the salary of the employee outside the class, so I would declare a getter here. The getter will return, the return type should be float, and you should use the keyword get and salary like this, get salary, and just return salary. Okay, so this is called as a getter. Similarly, we can have a setter where you pass some salary here and assign it to salary. And this getter should not modify the salary in any way. You should not be able to do something like this, salary equal to 100 or something. In that case, you must use the keyword const here. If you use const, then this method cannot modify any of the data members of the class. So as you can see, it starts showing red line here. So even by mistake, you cannot modify the member variables with the getter. Of course, for the setter, you cannot do because setter is going to modify the member variable. So only the getter will now be kind of a read-only function. And this is both, this is a write function. It's going to modify the members. Okay. So to the class, you can add getters and setters. And if I call it here, salary equal to, you just see out even arrow. As you can see, get salary would appear as a method here. And you can see that amount gets displayed at the end. So with little clarity, you can get the in main salary is this. This is through getter method. Okay. So same is true for setter. If I want to change the salary, you can change the salary using the setter, set salary. And here if I enter this as, let us say 20,000, the salary of the employee gets modified Now instead of 72,000, you will get it as 20,000 now, as you can see, because I am modifying the salary using the setter. So from outside the class, if you want to access the data members and also modify them, they should be done in a controlled way, and the way to do it is using getters and setters. Is that fine?
Can you scroll up a bit, sir?
Yeah.
That set salary and
Yeah. First, you need to understand why this constant is placed here, because this method should be read only. It should only return the values. And
Yeah.
one getter should return only one value.
Mm.
Okay. You cannot return salary and also employee ID and all that.
Okay.
Okay. So if you want to return employee name also, there should be one getter for it. So you can write like that, string get employee name. And again, make it read only and say return employee name. Okay, it should be a pointer. So this inline function has nothing to do with the class. It is just a normal function outside main. Inline functions are not called the way normal functions are. Okay, basically they are not called at all. They are not called. Okay, so then how this code is executed? It is executed by substitution. Sometime back in C, I mentioned about macros.
Like macro.
It is similar to macro.
Okay. So in this C++, we don't have a concept of macro, correct? Or we do have
No,
here?
we do have, because hash define is there, no?
Okay.
Okay, but they don't want to use that kind of a syntax. They want to use only methods, functions like that. So this is a good substitution for it. So wherever you call compute interest, this will be replaced by this statement. So the call doesn't happen. It is inline substitution, and this will be more efficient. And you should use inline function only if you have one or two statements within the body of the inline function. That you must remember.
So what is the use of this view perks? Meaning actually this view perks is kind of like the function which is outside the class which can be accessed from accessing, right?
Yeah. Any function, if you define outside the class and if it is to be used inside the class, then it should be a friend of the class. Okay.
Sir, inline function, can you repeat again, sir?
Yeah. See, we write normal functions. No, if I write like this and call it from main, for example, I'm just calling it from here. It is returning some value, no? So see out, let us say compute interest. I will pass some values here. Let us say some 1,000 rupees and time 2 years, and let us say interest rate is 5%, whatever. Now here the function call happens. That is, the control will be transferred from main to this function compute interest, and the execution happens here. So for every call, there is a overhead that all return address has to be pushed onto stack, the variables or values have to be pushed onto stack, and when you return, all the values from the stack should be popped off. So if the number of lines of statements within a function is very small, this is unnecessary overhead. Okay, to alleviate that problem, you just prefix the name of the function with inline keyword. Okay, so now what happens is the function at this statement, what compiler does, it will not call the function here. Instead, the substitution happens during compile time like this. You will get this statement substituted here.
Okay.
If you have made inline, no, even though you have written a function like statements here, compute interest you have written, no, that gets substituted. You pass some 1,000 rupees here and time as 2 years and interest as 5. So ultimately it generates code like this before executing. So it is,
Where are we calling that inline function here?
yeah, see, you will be calling, you are writing like this, compute,
Okay, we should call. Okay.
you should call, but
Mm.
at compile time, it will be
Substitution.
substituted with the value that you pass.
Okay.
The expression that I showed, no, 1,000
Mm.
into 2 into 5 divided by 100 comes in this place.
Got it.
Okay, yeah. So that is why unnecessary call to the function is avoided.
Okay. Okay.
All right.
And the same thing with the friend function also, right?
No, no,
We
no.
will have.
Friend function is a regular function
Okay, but we are declaring outside the class.
outside the class, and
We are defining outside
it
the
can
class.
be friend to many other classes also.
Okay. Okay.
Yeah. So it is a,
Okay.
it's like a trusted entity that you
Okay.
trust that function. It doesn't do any harm to the data members of the class. So such functions are required in many scenarios. So that's why that feature is provided.
So multiple classes should have that friend function declared. That's the
If
only thing.
required.
Okay.
Yeah. If those classes want this function, then they should declare them as friend.
Okay.
Okay. Okay. Now to summarize what we discussed today is we saw how an object is created, and object we know it is a entity, either it is physical or conceptual, and has unique identity. That is, every object that you create exists in a memory, and memory address itself is the ID of the object. Okay, and when you create object uh, with the normal way, that is employee E, the objects are allocated on the stack. But if you use pointer to create object using like employee star even new employee, then these objects are created in the heap. So if they are created in the heap, it is your responsibility to delete them. Okay. Similarly, if any data member is there in the class and if it is dynamically allocated space, then again in the destructor you have to delete it. All right. And classes normally will have getters and setters to either read the values of the data members which are private, and also set the values of the data members which are again private from outside the class. And a concept of a friend function is also provided to have one function which will be trusted entity and which will do carry out some operations on the data members. And inline function is a special feature of C++ which is a substitute for the macros. So if a function has one or two statements, it is better always convert that function into inline to avoid unnecessary stack overheads. Okay. So we shall see more on these things in our next lecture. All right.
Sir, can you just execute this once again, sir? That get salary and set salary thing, how it is, please?
Yeah. See, get salary in main, the salary is modified now, 2000. Okay.
Okay.
So set salary I'm giving 2000, so that is set, and I'm displaying that in memory in main salary would be 2000 hereafter. As you can see here, I have set it, and only after that I'm calling get salary. If I suppress this set salary, the original salary will come, which is 72,000. Okay.
Okay.
All right. All right. So I will put up the assignment to for today's session, and you just try those things. All right.
Sir, just copy that inline function in a chat, sir.
Okay. So you can write any inline function. Just for illustrative purpose, I have taken a very simplistic use case.
Maybe in this chat only you can
Yeah,
just
yeah,
paste
I'll
it.
do that.
Sir, if I run that inline program, but I'm not getting any output for that.
Inline,
Yeah, 14. I mean, we are calling it right after E. 48 line. See
yeah,
your compute
here
interest. It should display some output, right?
it is displaying. No, I showed you.
Okay.
It's
No value
coming.
is displaying it
It is
outside,
coming.
right?
It is getting mixed up somewhere here.
Okay. Yeah.
Maybe there should be endl somewhere here.
Yeah.
Or you can put some interest equal to
Okay.
something like that,
Okay.
so
Got
that
it.
you know whether it is displayed or not. Right? 100
Yeah.
rupees interest is accrued. All right.
Thank you. Yeah.
Okay, we'll close for today then.